Hello everyone, Evan and Eric here again to help you with another physics problem. Today we'll be doing a problem that has to do with projectiles and more or less energy. So the problem reads, a cannon fires a 5 kilogram projectile straight up at an initial speed of 100 meters per second. When the cannon is fired, it releases 5,000 joules of energy, and assuming there's no air resistance. We want to calculate A, the maximum height the projectile will reach, B, the speed of the projectile at a given height, and C, the speed right immediately before hitting the ground. So to start this problem, let's get a sketch going so you can understand what's going on. So what we have basically is a cannon, and it has a projectile being launched out of it. We'll call this ground level, this will be h equals 0. Then it will be going up in a straight line until it reaches its apex. That will be h equals max, which we are trying to solve for. So first we have to identify the system as either being open or closed. And since in the problem it states that we have a release of 5,000 joules, we know this is an open system. So to start it off, we need to write the law of conservation of energy, which is the sum of the energies initial equals the sum of the energies final. So from there we can break it down even further into the sum of the initial potential energy plus the sum of the initial kinetic energy equals the sum of the final potential energy plus the sum of the final kinetic energy. So from there we can plug in our equations for potential and kinetic energy, which we know are mass times gravity times the height, and we'll put an initial for the height there. And then for kinetic energy, it's 1/2 mv, that's v initial, squared. Then we also need to include our work here, so we include that to the left side. We'll just leave it as w for now. And then we do the same thing for this side, which will be mgh final plus 1/2 mv final squared. So from there we can plug in values. We know our initial height is 0, so that will become a 0. Then we have 1/2 mass, which is 5 kilograms. Our initial velocity is 100 meters per second squared. And then we have our work, which in this case is 5,000 joules. And since it's being released, we're subtracting 5,000 joules. And then our potential energy on the other side will be the mass again, 5 kilograms, times gravity, 9.8 meters per second squared, times the final height, which we are trying to solve for. And then kinetic energy will be 0 because the velocity at the top here will be 0. So if we simplify this down, we get 25,000 joules minus 5,000 joules. And we get that equal to 49 kilograms meters per second squared times the final height. So this becomes 20,000 joules equals 49 times the final height. So we get the final height is equal to 408.16 meters. So that's part A. Now part B is asking for the speed of the projectile at 200 meters. So we're basically going to have the same setup as last time, in which we have the sum of the energies initial equals the sum of the energies final. So again, we break that down into U initial, K initial equals potential final, kinetic final. So if we plug in our values that we want to get here, we'll get mgh plus 1/2 mv squared equals mgh plus 1/2 mv squared. So the initial energy, again, we have no potential energy since it's starting at the ground, so again it's the same as last problem, 1/2, 5 kilograms, velocity squared, 100 meters per second. And then this time we do have potential and kinetic energy as it is going up. So we'll have 5 kilograms times 9.8 meters per second squared and we are given our height, which is what we want to find the speed at, which is 200 meters, so we'll plug that in for the height. And then we have 1/2 5 kilograms, and then v squared, which is what we are going to try and solve for in this equation. So this, again, we also have our release of 5,000 joules. So again, this side will come out to 20,000 joules, and when you simplify the other side, we get 9,800 joules plus 2.5 kilograms v squared. So from this, we subtract the 9,800 from this side, get 10,200 joules. That equals 2.5 v squared. Then we get v squared is equal to 4,080, and v is equal to 63.87 meters per second. And then we have solved for part B. So now for part C, we want to find the speed immediately before hitting the ground. So, yet again, we're going to have almost the same setup. So, sum of the energies initial equals the sum of the energies final. We know our total initial energy from the first two problems that we did is 20,000 joules, so we can just put that down. And then our final energy, we're going to have potential and kinetic. But since the height is going to be at 0, which is right at the ground, that's going to end up to be 0. So we'll have 20,000 joules equals 1/2 m, 5 kilograms, v squared. And so when we solve this, we'll get 20,000 joules equals 2.5 kilograms, v squared. And when we solve for that, we get v squared equals 8,000. And then we get v equals 89.44 meters per second. And we can do a quick check on this. Since we had an initial speed of 100 meters per second when we launched, and we released energy, it's common sense to know that when it comes down, it will be coming down slower than it initially had. If there had been no release of energy, it would have stayed at 100 meters per second because there was no air resistance. Hope this problem was helpful. See you next time.